Okay, before we start with questions, I just want to talk about non-parallel and non-zero vectors. This subtopic or this properties for this type of questions always being asked in the SPM examination. So what is non-zero non-parallel vectors? If we have vector H A equals to KB, where A and B are non-zero, non-parallel vectors, both are not zero and both are not parallel, then the properties is we must have H equals to 0 and K equals to 0. Just remember that whenever you come across with question for non-zero, non-parallel vectors. Okay, for example, find the value of H and K if we have this vector, this equation, such that A and B is not parallel to each other. So what you do is, we have 6A minus 5HB equals to 2HA plus 3KB. What we need to do is we need to separate vector A with vector A, vector B with vector B. So I will just rearrange. So we have 6A minus with 2HA equals to 3KB plus with 5HB. So I'll just bring that to there, that to there. So now I will factorize vector A. So we have 6 minus 2H. A equals to 3K plus 5HB. And since A and B is non-zero and non-parallel, so we will have 6 minus 2H equals to 0, since this properties here equals to 0 equals to 0. So therefore 6 equals to 2H. H is just equals to 6 divided by 2. H is just equals to 3. The same goes for that component here. 3K plus 5H must equals to 0, since it's non-zero, non-parallel. So we have H. 3K plus 5 times 3 equals to 0. 3K is equals to negative 15. Therefore, K is equals to negative 15 divided by 3 equals to negative 5. Which means that for A and B to be non-zero and also non-parallel vectors, then H needs to equals to 3 and K needs equals to negative 5. This type of question rarely came out in SPM, but still it is in your syllabus. Okay, let's look at example. Given that vector EB is equals to 10, 14, OB is equals to 4, 6, and CD is equals to M7, all in column form, find the coordinates of E. So if you want to find the coordinates of A, you have to find the vector OA, basically, because say, okay, so you want to find the coordinates of A. If you get the vector OA, then you will know directly what is the coordinate of A. So we need to find the vector OA. So back to basic. It is given, we are given with vector AB. And from previous lecture, we know that vector AB, in terms of position vector, is just back minus front will become OB minus with OA. So do we have OB? Yes, we do have OB, and we do have OAB. So if you want to find, our aim is to find OA. So what I will do is just bring OA to the left hand side and AB to the right hand side. So this will produce OA, vector OA is just equals to OB minus AB. So from the question given that OB is equals to 4, 6 and AB is equals to 10, 14. So we should get component I minus component I, top, top, bottom, bottom. 4 minus 10 is negative 6. 6 minus 14 is negative 8. So which means that coordinate of A is just equals to negative 6, negative 8. So that should do for question A. For question B, the unit vector in the direction of OA. So we want to find the unit vector in the direction of OA by formula. Unit vector, the symbol hat represent the unit vector in the direction of OA is just equals to 1 over the magnitude of vector OA times with vector OA itself. Okay, so in other words, you can also rewrite that as, vector OA divided by its own magnitude. Because if I bring that top here, it's just vector OA. It's the same thing. Okay, same formula. So what is vector OA? When I deal with unit vector, I like to use the INJ form. So vector OA is just from here. We know that it is just equals to negative 6i minus 8j divided by the magnitude. It's just equals to square root of negative 6 squared minus plus with square root of negative 8. Plus with negative 8 squared. So you press your calculator, you should get 10. Okay. Now you can simplify things because we can actually factorize the top. So say I'll bring 2 outside. Becomes negative 3i minus with 4j over 10. So simplify, becomes 5. So final answer is negative 3 over 5i minus 4 over 5j. Okay. Or you can also write your answer as negative 3i minus 4j over 5. I think both answers can be accepted. Okay, now we look at C. Okay. The value of M if CD is parallel to AB. Okay. If CD is parallel to AB, there exists a constant. I would put as maybe lambda, such that CD equals to lambda AB. Okay, this is the fact when you deal with parallel vectors. So what we need to do here, just copy down. So we have M7 equals to lambda times with AB is just 10, 14. So if I multiply inside, because lambda is just a constant, so M7 is just equals to 10 lambda 14, sorry, yeah, it's the same thing, 10 lambda 14 lambda. So just take note that this is in the column form. Okay. So means that now we can compare component J and J first, because we have all the information there. So 7 is equals to 14 lambda. Therefore, lambda is just equals to 7 divided by 14. So lambda is just equals to 1 over 2. Now we have the value of lambda. Next, we compare the component of I. Therefore, m is just equals to 10 times with lambda. It's just equals to 10 times with 1 over 2. So the value of m is just equals to 5. That is your final answer. Okay, for our next example, given that OABC is a parallelogram, okay, such that OA is equals to 3i plus j and OC is equals to 2i plus 3j. So maybe we can just draw our parallelogram. And we know that when we talk about parallelogram, that should be parallel to that one. That side should be parallel to the other side. So just take note on those properties. Okay. So we have O, A, B, C randomly. Find OB. Okay, for question A1, find OB. OB is just equals to maybe OC plus CB or OA plus AB. Okay, so maybe write this OB is just equals to OC plus CB. So you take, oh, you are not given OC. Maybe we should use OA plus AB. Try OA plus with AB. Okay. And we know that vector AB, since it's parallel to vector OC, so vector AB is just equals to vector OC. They have the same length, they have the same direction, therefore they are the same vectors. So it's just equals to O. So since AB is just equals to OC. Okay. So do we have OA? Yes, we do have OA. Here I use the column vector 3, 1 plus with OC is just 2, 3. Okay. I just use the column vector. So 3 plus 2, 5. 1 plus 3, 4. So vector of OB is just 5, 4 or 5i plus 4j. Okay. Both answer can be accepted. Okay, that is for A1. So A2 asks you to find the unit vector in the direction of OB. So again, unit vector, just put a cap. It's just equals to the vector itself divided by its magnitude. Okay. So the vector itself is just 5i plus 4j divided by the magnitude. 5 squared plus 4 squared, 5i I plus 4j divided by square root of 41. So the answer is 5 square root of 41 I plus 4 over square root of 41 j. Okay, now we move to the question B. T is a point such that CT equals to 16I plus 3j. Find AT. Okay. Question B. Wait, let me put that aside first. So we've done question A. Now we move to question B. Given that vector CT is equals to 16I plus 3j. Okay. So we want to find AT. We want to find AT. AT is just equals to back minus front. Just equals to OT minus OA. But do we have OT? We do not have OT, but we can find OT from here. We know that CT is just back minus front. This is just equals to OT minus OC equals to, let me put into column form, 16, 3. Therefore, vector OT is just equals to vector 16, 3 plus with vector OC, which is just 16, 3 plus with vector OC is equals to 2, 3. It's given in the question. So vector OT is just 18, 3 plus 3, 6. 18I plus 6j. Okay. So which means equals to OT is 18, 6 minus with vector OA, that one. So this is just 3, 1. The final answer should be 15, 5. Or if you want to put in ij form, it becomes 15I plus 5j. Okay. Question B1. This is B1. We are moving to question B2. Okay. Determine if O, A, and T are collinear. Okay. So when we talk about collinear, we must prove that by concept, if O, A, and T are collinear, then there exists a constant. I see, maybe I write as lambda such that any combination OA is equals to lambda AT. Okay, so can we do that? Do we have OA? We do have OA. So OA is just equals to 3, 1 to lambda times AT. AT, that is AT is just equals to 15, 5. okay, in column form. So 3, 1 equals to lambda, 15 lambda, 5 lambda. Since lambda is just a constant, I can multiply inside. So check for the first component, 3 equals to 15 lambda. Therefore, lambda is equals to 3 over 15. So lambda is just equals to 3, 1 over 5. So the second part, check. So if you see, we've done for that one. Now we check for that one, the j component. 1 equals to 5 lambda. So lambda equals to 1 over 5. So we get the same since the value of lambda is equal for both components I and j, therefore O, A, and T are collinear. Okay, so it's proven that O, A, and T are collinear. Okay, now let's have a look at example question. Suppose that the figure shows points A, B, C with position vector A, B. And C respectively relative to the origin O. The point B lies on AB such that AP is to AB is equal to 3 over 4. The point Q lies on OC such that OQ is to QC is equals to 2 is to 3. So before you start doing any question, read the question first. Okay, the first one, express AP in terms of vector A and B, hence show that this. Okay, so first we need to express vector AP in terms of A and B, but I don't think it's possible. Can we do that? Yes, we can. It is given that AP is to AB is just equal to 3 is to 4. So for the first part of that question, we know that the ratio of AP is to AB is just equals to 3 is to 4. Change that into ratio form. We will have AP over AB, change to fraction form. So this is just equals to 3 over 4. Therefore, AP is just equals to 3 over 4 of AB. Can we find AB? Yes, we can. If you look at the diagram, AB is just equals to AO plus with OB. Okay, so again, 3 over 4 times with, from the diagram, AB is just equals to AO plus with OB. So equals to AO plus with OB. Or we can have a look at this way. We know that make it easy. Back minus position vector back minus position vector front. So OB, vector OB minus with vector position vector OA. Okay, so which is just equal to 3 over 4. Do we have vector OB? Yes, we do. It's just B. OB is just vector B. Okay, so it's just B minus with OA is just vector A. Okay, so that is your final answer, or you can write it 3 over 4B minus 3 over 4A. Okay, next we move to the second part of the question. The second part of the question wants us to show that vector OP is just equals to 1 over 4 of vector A plus with 3B. Okay, why do I use the symbol wiggle down here? Because if you do not use symbol wiggle, you have to use bold small letter. A bold small letter is just equals to A wiggle, and both of these is the symbol of vector. So if you have bold B, if you don't want to write bold B, you need to write B with the wiggle symbol down there, okay, down of the letter, right? Okay, we need to show this. From the picture, we can see that OP is just equals to OB plus with BP. Okay, so we can say need to show this. OP is just equals to OB plus BP. Vector OB plus with vector BP. Okay. So which is just equals to vector B plus with vector BP. So our challenge is to find vector BP. How do we find vector BP? Vector BP is just equals to negative of vector PB. Okay. So equals to B plus with negative of vector PB. How do we find vector PB? From this question, we know that AP is to AB equals to 3 is to 4. Means that AP is 3 parts, AB is 4 parts. So therefore, PB here is 1 part. So I would say that vector PB is just equals to 1 over 4 of vector AB, right? Let's do that. So that let us just see. So again, the fact is that B plus with negative of vector PB, again vector PB is 1 over 4 of vector AB. So 1 over 4 of vector AB. So equals to B plus with minus 1 over 4 of vector AB. Do we have vector AB? If you look at the picture, vector AB is just AO plus OB. And then actually we've already find vector AB, which is just B minus A. You can have a look at the picture as well. So this is just B minus with vector A. Okay. So now we need to simplify things. B minus with 1 over 4 B minus 1 over 4A. What I did is I just multiply that inside, so positive negative becomes negative, so which is just equals to, let's see, B minus with 1 over 4B plus with 1 over 4A. Right, so B is just 4 over 4B minus 1 over 4B plus 1 over 4A. So the same component, so we have 4 minus 1, 3 over 4B plus with 1 over 4A. Factorize 1 over 4, bring outside. We have 3B plus A, hence equals to 1 over 4 A plus 3. I just rearrange B. Okay, it's proven. It's a long workings, but you have to do it one by one so that you will not get confused. Maybe you should rewind this tutorial and go through the procedure, the steps one by one. Now for question 2. Find PQ in terms of A, B, and C. If you want to find PQ, and we know that back minus front is just OQ minus OP. Okay. Do we have OP? Yes, we have OP. So it's given that minus with OP is 1 over 4 times with A plus 3B. Okay. The problem is now OQ. We need to, if you look at the question, wants to find PQ in terms of A, B, and C. So maybe the term C here is in OQ. So if you see OQ and OC, right? If you see the relationship given from the question, it is given that OQ is 2 parts, then QC is 3 parts. So this is 2 parts, this is 3 parts, then the total parts are 5 parts. Okay, and means that OQ is just 2 over third of OC. Okay, and not 2 over third, sorry. If the total parts is 5 parts, then means that OQ is 2 over 5 of the whole parts OC, right? And we know that OC is just C. So 2 over 5C. So which means that OQ again is just 2 over 5 of OC minus with 1 over 4A plus 3B. I just copy down the vector. So again, this is just 2 over 5 of vector C minus with 1 over 4 of vector A plus 3 over 4 of vector B. So final answer should be 2 over 5C minus 1 over 4A minus 3 over 4 vector B. So that is your answer for question 2. Okay. Final answer. Okay, given that for question 3, given that 5PQ equals to 6BC, 5C in terms of B. So for question 3, given 5 question PQ, vector PQ is equals to 6 vector BC, find C vector C in terms TERM of A and B. Okay, so it goes back to the question 5PQ. Do we have PQ? Yes, we have PQ. So 5PQ slightly hard. 5 times vector PQ equals to 6 times vector BC. Okay, so vector BC is just BC. You know that BC is just equals to OC minus OB, back minus front. OC is just equals to C minus with OB is just equals to B. So we need to expand and rearrange. Right, here multiply 1 by 1. Okay, so we should get the first one 5 times 2 over 5 C minus 5 times 1 over 4 A minus 5 times 3 over 4 B. Okay, simplify, we have 2C minus 5 over 4A minus 15 over 4B equals to 6C minus 6B. So the next one, I'll bring C to the right hand side and B to the left hand side, rearrange. So you should get 6B minus 15 over 4B minus 5 over 4 4a equals to 6c minus 2c. Okay. So you should get here 9 over 4b minus 5 over 4a equals to 4c, right? So c is just equals to 9 over 4b minus 5 over 4a multiply with, this is 4 over 1. If you bring to the left hand side, it becomes 1 over 4. So now you multiply each and single. So it becomes 9 over 16b minus 5 over 16a equals to c. So I can rewrite that as 1 over 16, 9b minus 5a equals to c. So it means that c is just equals to 1 over 16 times with 9 times vector b minus 5 times vector a. So that is should be your final answer for question 3. Alternatively, you can write your answer as 9b minus 5a over 16. Still, you get the same answer. Alright, now we move first to a harder question. I'm not sure that this kind of question will be asked in your IGCSE examination or not, because we are having a new syllabus this year. But obviously, this kind of question will not be asked in SPM, but I'm not sure if they will ask. Okay, but somehow it's in the requirements of your IGCSE syllabus, compose and resolve velocity. So I assume this kind of question can come out in your IG examination. So let's have a look. Okay, the diagram, which is not drawn to scale, shows a horizontal rectangular surface. One corner of the surface is taken as the origin O. So this corner is taken as origin O. And we have I and J components along the edge of the surface. A fly starts at point with position vector of 1, 12. Okay, so it's good for us to draw just to illustrate the picture. Sorry. So O. So a fly starts at the point of position vector. So 1, 12. So it means that I would say OF in terms of position vector, or we can say displacement of the fly. So it's just equals to 1, 12. So I represent D as the displacement. Okay, in terms of column vectors, and it crawls across the surface with a velocity of 3i plus 2j. Means that the fly moves right up, so it moves up something like that. Okay, so this is it cross that way. So the second information we have, velocity of the fly is not it's not displacement, this is velocity. So that should be 3, 2. So this is displacement vector, this is velocity vector. At the instant that the fly starts crawling, a spider, oh there's a spider, S at the point in which position vector is 85I plus 5J. So I assume that the spider probably is more to the right and down here. This is the spider. So we have displacement of the spider is 85, 5. Okay. Sets across the surface with a velocity of negative 5k. So it moves with negative 5k. So we have velocity of spider is negative 5k, right? So it means that it's moving on to the left and going up, sort of like that, the movement of the spider, right? Something like that. So fly starts here, crawls towards that direction. There's a spider here at this point. So fly starts here, goes towards that direction. There's a spider here, crawling, flying there, going there. And given that the spider catches the fly, so it goes up, up, pop, spider, catch, fly. So when the spider catch the fly, we can say that the position vector is the same. Displacement, so which means that fly and spider meets here. So I would say at the moment when the spider catches the fly, OF, displacement vector of the fly, is just equals to displacement vector of the spider. And just now we described displacement as df is just equals to displacements of spider at the moment when the spider catches the fly. Okay. Given that the spider catches, so I calculate the value of k. So now we want to find the value of k. All right. We know that basically we know that how to put it in words. We know that velocity is equals to displacement over time. So displacement is equals to velocity multiplies with time. Okay. Um, since df is equals to ds, I would put the symbol apostrophe up there just to indicate that the final displacement. Okay, so final displacement of the fly is equals to final displacement of the spider when the spider catch the fly. So from the triangle, we know that this final displacement in terms of fly is just equals to OF plus with that. Okay, so the initial displacement plus with here displacement of that. But we do not have displacement here. We have the velocity. Okay, we have the velocity. We do not have the displacement. To have the displacement, we need to time with t. So we have 2 times with t. So this is just vt. Okay. Again. Um, right. Final displacement of the fly is just equals to displacement of OF plus displacement of F to here. But here we do not have the displacement vector, but we have the velocity vector, which is just um, 3, 2. But we need displacement. In terms of displacement means that we need to have OF, vector OF, plus with displacement is just velocity, 3, 2, times with the time. So we get in terms of displacement, right? Here, in terms of displacement. Now, for ds, right? Again, final displacement of the spider equals to initial displacement of the spider, which is just OS, plus with this displacement vector. But we do not have that displacement vector. Instead, we have negative 5k in terms of velocity of the spider. So we need to here VF times with time to get displacement, OS times with velocity of spider times with time to get the in terms of displacement. So in a sense that we have OF. What is OF? It's just 1/12 plus with VF is just 3, 2 times with time equals to OS, initial displacement of the spider is 85.5 plus with VS is negative 5k times with time, right? So all of these are vectors. So we have 1 plus 3t. Down you have 12 plus 2t is equals to 85 minus 5t, 5 plus kt. Okay, so now we have component I and component j. Right. We look at the first part, the top component first. So we have 1 plus 3t is equals to 85 minus 5t. So rearrange 3t plus 5t equals to 85 minus 1. 8t is equals to 84. So t is just equals to 84 over 8. Okay. Now, look at the second component. 12 plus 2t equals to 5 plus kt. So, 12 minus 5 equals to kt minus 2t. Okay. 7 equals to k minus 2t, or equals to k minus 2 times with 84 over 8. So k minus 2 is equals to 7 times 8 divided by 84. Two over 3 equals to k minus 2. Therefore, k is equals to 2 over 3 plus 2. So the answer is 8 over 3. That is the value of k. Okay, now let's take a look at one more example. At 12 hours, a ship has position vector that position vector relative to a lighthouse. Means lighthouse is our reference, where I is the unit vector due to east, and j, we should know north, south, east, west. So I means that this is I, this is j. Okay, east and j is unit vector due to north. The ship is traveling with the speed of 20 km per hour and the direction of 3i plus 4j. Okay, what information do we have here? I think before that, let's just draw. So this is your lighthouse, and position vector of the ship is for 54i and 16j maybe here. The ship starts there, and the initial displacement of the ship is 54.16. Okay. The ship traveled with a speed of 20 km per hour in the direction of 3, 4. So direction of the vector of the ship is 3i plus 4j. Okay. Show that position vector of the ship at 15 hours is 90i plus 64j. So after the ship travels for 3 hours, because the ship starts at 12 hours, and after it travels 3 hours, what is the position vector? So let's say it goes that direction. After 3 hours, what is the position vector of the shape. So we want to know that vector. So we will say the position vector of the shape after 3 hours is just equals to the initial displacement of the shape plus with uh, displacement of S. Both needs to be in terms of displacement. Okay, so but the thing is we do not have this displacement here. We have that one, but we do not have this one. But what do we know? Here we need to find the velocity of the shape, and then we need to multiply by t. In this case, t is just equals to 3. Then only we will get the displacement in terms of displacement, because we know that displacement is just equals to velocity times with time. So we need to find the velocity of the ship. How do we find the velocity of the ship? What information do we have? You know that unit vector of direction is equals to unit vector of velocity. And I think I did mention it previously. If you notice, I did mention it in the first part of the video that unit vector of direction is just equals to unit vector of velocity. So back to our question. Unit vector of the direction means that direction vector divided by its own magnitude is just equals to vector velocity divided by its magnitude. Okay. And we also know that from our previous class that the magnitude of a velocity vector is just speed. Okay, therefore, we can say that magnitude of velocity is just equals to 20 km per hour because it's given the speed. So fact that magnitude of a vector velocity is just equals to speed. So now we have velocity vector over with 20 is equals to direction vector given in the question. Direction vector is 3i plus 4j. Divided by its magnitude is just 3 squared plus 4 squared. So velocity vector just equals to 20 times with vector 3i plus 4j over 5. Okay, so 5, 1, 5, 4. So velocity vector multiply vector of velocity is just equals to 12I plus 16J. So now we have the velocity vector for the shape. Okay, so which means that in terms of displacement, we need velocity vector, which is just 12, 16 multiplied with time is 3. So in a sense that initial displacement of the ship we have, do we have initial displacement of the ship? Yes, it's just 54, 16. So in terms of displacement, plus with displacement of the ship here, it's just velocity times with time. Velocity vector is just equals to 12, 16 times with time taken, 3 hours, because it's from 12. Okay, so 3. So we start 54 plus with 36, 16 plus with 48, vector. So 90, 64. So the displacement of the ship after 3 hours is 90I plus 64J. Okay, let me check whether the answer is correct or not. Yes, the answer is correct. Okay. Now, for question 2, this is question 1. Find the position vector of the ship T hours after 12 hours. So ds is just equals to initial displacement plus is velocity of the ship times with time. Okay, so it's just 54, 16 plus with 12, 16 t. Okay. So the final answer is just 54 plus 12t, 16 plus 16t. Okay. So that is answer for question number 2. Position vector of shape after 12:00. So this t, value of t depends on the time taken after the ship travel. For example, if we have 15 hours, means that the ship travels for 3 hours. Okay, so this is just random. Alright, I think that's it for this chapter. I hope you understand today's lesson. Yes, this chapter is packed and slightly harder than other chapters, but still bearable. So do lots of practice to make sure that you can master this chapter. Okay, bye-bye.